Okay, so this is actually be a pretty quick one. So this is for linear programming, but on the topic of degeneracy. So really what that is I have an example here where I want to maximize this equation, this objective function where it's x1 plus x2 such that 2x1 plus x3 is less than or equal to 6, 3x1 minus x2 is less than or equal to 4, x1 minus x2 minus x3 is less than or equal to 0, where all three of those variables, x1 through x3, are greater than or equal to 0. So really what this says is that if you have a 0 on the right-hand side of your um, system here, there's a chance that your linear, that your you could have that you could have degeneracy, which basically means that when you start your simplex method, there's a chance that your simplex method can loop and you'll be stuck in an infinite loop, right? So don't let the term degeneracy kind of fool you. So just to kind of give it a little format here, let's just say you have x1, x2, x3. Yeah, you're gonna have your slack variables w1, w2, w3 here, right? Then you have your right-hand side. So in this case, you have, let's just say, 0 here. It's gonna be, right, it's gonna be -1, -1. This can be a 0. It's gonna be 0, 0, 0. I'm doing this really fast. Right-hand side is going to be 0. What this is basically saying is you're going to have different slack variables that are going to go down here, right? And you're going to have different right-hand sides that are going to be filling this up, unless let's say maybe the very bottom one is a 0. If you keep doing the simplex method, so there's a chance that you may actually get this same matrix back, in which case you're actually just redoing the problem again and again and again, and so you're stuck in an infinite loop. So really what this is just saying is that if you have a constraint where the right-hand side, is equal to 0, this could happen. So just be careful of that. And that's what it means to have a degenerate linear programming problem.